this chapter, we will be studying systems of equations and inequalities. In this lesson, we will be looking at quadratic inequalities in two variables.
Hi everyone. So in this lesson we're going to look at quadratic inequalities in two variables. Now we did it before where we were graphing lines and looking at the inequalities that you got from those. We're going to do a very similar thing with parabolas now. So a quadratic inequality in two variables can be written in one of these forms here. Okay. Now actually there's even more than this, but you get the idea. It's going to be y is greater than the quadratic, y is less than the quadratic. Now remember what that means. Okay. This means right here we're going to shade above, and because we don't have the or equal to there, that is going to be a dotted line. This one is going to be, because y is less than, it's going to be shade below, and because again there's no or equal to, this is going to be dotted. This one here, because it's greater than or equal to my quadratic, is going to be shade above. And now because it's or equal to, we'll have a solid line. And this one here will be shade below because it's y is less than or equal to. And in this case, again, it'll be a solid line. Now, I spent a little bit of time to talk about that only because I don't want you to think this is any different than what we had done before. In fact, it's exactly the same. Where the difference is going to pop up is in the shape, and there's going to be a tendency to want to interpret this a little bit differently, and I'm going to try to help you get through that. Now, we're going to look at there are three different forms of the quadratic that you need to pay attention to. There's the vertex form, factored form, and the standard form. And so these inequalities that we're going to come up with could be written in any of those three different ways. And your graphs are going to look something like this. And I really appreciate this being here in this particular lesson at this point. So y is greater than, okay, that parabola, dotted line, and you shade above. Now I know it looks like you're shading inside the parabola, but really every dot here that you have on the parabola here, if you just shade up, this is actually above. The easiest one to do this to is the vertex. Pick the vertex, greater than means shade up. Now that does look like it's inside, but this idea of inside, outside becomes a little bit more confusing if that's what you're going to stick with. It's much more consistent just to say above or below. So here this is greater than or equal to the parabola. Pick a point on there, above. Okay. This is less than the parabola, so it's a dotted line, and we shade below. So take your vertex, shade below. Take any point there, shade below, shade below. Solid line, and again, less than, so shade below. So that's what that would look like. Now, we can use zeros, we can find the roots, sketch the graph using the vertex and whatnot. There's multiple different ways you can sketch those parabolas. You've already gone through it. And when I go through the examples here, I'll bounce back and forth between a couple of different methods there. And then you can use the test point if you want to test to see whether or not you're going to shade above or below the parabola. Now I know right here they're using the words inside and outside, and I get why they do that, and that works totally fine. That's great. I want to try to keep you thinking about above and below the parabola, because that's going to be more consistent with some stuff that you'll do later on. Anyway, so let's just take a look at some examples here and see what we can make of them. Okay. Hi everybody, we're going to take a look at a few inequalities here. Y is greater than x squared minus 4x minus 5. Okay, now I know that says here check the answer with your calculator, and we can certainly plug that in if we want to, but the truth is to check that in your calculator you kind of need to know exactly what it is you're looking at before you get to that point. So actually let's just graph this thing. So don't worry about the greater than at this point here. What we want to do to start off with is we want to graph the equal to x squared minus 4x minus 5. Okay? Now, there are a couple of different ways that we could do that. One way we could do this is to complete the square and to find the vertex there. So that would be x squared minus 4x. I'm going to push that negative 5 way off to the side there. And then I'm going to take half of that negative 4 and squared. So half that 4 is negative 2. Squared is going to be positive 4. I don't need the negative to complete the square to get that perfect square trinomial, so I'll take that negative out. And then that's going to factor down to x minus 2 squared minus 9. So there's the quadratic that I'm interested in. I know it's got a vertex now of positive 2, negative 9. So I'm just going to go to my grid over here. Positive 2, negative 9. We're right down there. I also knew, and I could figure this out right from the beginning here, that it had a y-intercept of negative 5. That was easy enough to take a look at. So that's going to be right there. And because of symmetry, I know that it'll go through a point right there. So then my parabola is going to open up. And I know that I'm going to use a dotted line here. I don't exactly know where I'm hitting the x-axis there, and that's okay. So there's my dotted line. Okay, now I need to shade, look at that right there. Y is greater than the parabola. Now again, it's a dotted line, okay, because there's no or equal to there. It's above. Y is greater than. So every point that I need has got to be above this one. Now, when you start getting a really, really steep line like that, I know that it becomes hard to tell where above is. So what I would do here is pick the one point where it's clear, where above and below are abundantly clear, and that's the vertex. So if I want to shade above the vertex, that's up here. That is going to give me this area right here. If you want to describe it this way and say it's within the parabola, okay, but it really is above the parabola. Okay? So anyway, hopefully that gives you a sense of how to do that. Now that's one way that you could graph that. Let's take a look at another one here. In this case, we've got y is greater than or equal to negative x squared minus 2x plus 3. Okay, maybe in this case, what I do, whoops, I don't know why I left the negative, the equal to out there. Maybe in this case, what I do here is I take out the negative and leave this as x squared plus 2x minus 3. Okay? Now, I'm going to graph this one, let's say, using the vertex, sorry, not the vertex form, the root form. So to do that, what I'm going to do to start off with, I'm going to ignore the inequality, because I don't really need that right now. I'm just going to focus on this expression. And what I'm going to do is factor this so that I can get the x-intercepts there. Now, I need the factors of negative 3 that are going to add to positive 2, and that's going to be positive 3, negative 1. So my x-intercepts here are going to be negative 3 and positive 1. So over here on my grid, okay, negative 3, positive 1. Whoops. Negative 3, positive 1. Now that doesn't actually give me enough. Now I know that this is going to open down, but what I don't know is where the vertex is. It would help me if I knew that, but I can actually figure that out pretty easily because I know that my vertex is going to be halfway in between the two x-intercepts. I mean, it has to be because the vertex lies along the axis of symmetry, which cuts this parabola in half. So that means, if you want to think of it this way, the p-value of my vertex, because we usually think of it as p comma q, is going to be the sum of my two x-intercepts divided by 2. So what's that going to be? It's going to be negative 2 divided by 2, or negative 1. Okay, so I know, okay, that my axis of symmetry is going to lie over here along that line, x equals negative 1. Now, if the x value here is negative 1, let's go back to our parabola here. If I plug negative 1 into here, negative 1 squared is going to be 1. 2 times negative 1 is going to be negative 2. So 1 minus 2 is negative 1, minus 3 is negative 4, and then the negative in front makes it positive 4. So if I plug negative 1 in, I get a y-coordinate of 4. That's got to be the y-coordinate of the vertex. So now, without completing the square, I know that the parabola is going to go through the point negative 1, 4, and it's going to swoop down like this. Now I'm going to use a solid line. Whoops, sorry, you can't see that. Start at the point negative 1, 4, and I swoop down. I'm using a solid line because, I'm sorry, for a second there I lost track of where my work was. because it's greater than or equal to. Okay, so it's that or equal to that makes this a solid line. Now, I go back to my inequality. Greater than or equal to, greater than. So I'm going to look at my graph here. Here's my vertex. Greater than is this way. So that means I'm shading outside or above the parabola. Now, if I want to double check this using a test point, I can certainly do that. So I tell you what, let's pick a test point 0, 0. Let's test 0, 0. Now, according to my diagram that I've just drawn, 0, 0 shouldn't satisfy my inequality because I've shaded everywhere on the other side of the parabola. So let's just check this out here. This should lead to a false result here. So is it true, let's go back up here, that 0 is greater than or equal to negative 0 squared minus 2 times 0 plus 3? Well, that's going to be, is 0 greater than or equal to, well, okay, 0 squared, negative, that's just 0. Negative 2 times 0, well, that's just 0. Plus 3 is 3. Okay, is 0 greater than or equal to 3? No, that's false. So what that means is I wouldn't shade over the origin, I would shade on the other side of the parabola. So yeah, that's exactly the way that should look. Wonderful. Okay, let's take a look at another one here. Y is greater than 2x squared minus 12x plus 16. Okay, so I'm going to factor out that common 2. So x squared minus 6x plus 8. And actually, I'm going to put this in that root form again. It's very likely that you haven't seen a lot of questions done using that factoring and finding the vertex that way. So I'll just do this again so you've got another example of that. So we're going to focus on the expression here. We're not going to worry about the inequality just for right now. So I'm looking for factors of 8 that add to negative 6. Okay, and that's going to be x minus 2, x minus 4. So my two x-intercepts here are going to be positive 2, positive 4. So I'll come over to the graph that I'm given. Positive 2, positive 4. Now the beautiful thing about this is I can tell right now, I can see this so clearly, that the value halfway in between, my axis of symmetry has to be halfway in between those. Well, that's going to be 3. Now if you don't believe me, we would just add those two values, divide by 2, so it's going to be 6 over 2. It is 3. Now let's go back to our expression here. Let's plug 3 in. So 3 squared, or let's do it down here. 3 squared is 9, minus 6 times 3 is 18. So 9 minus 18 is going to be negative 9, plus 8, okay, is going to be negative 1, times 2 is negative 2. So my vertex is going to be 3, negative 2. Okay, it is easy enough for me to find that x-coordinate of the vertex, and then I just plug it into the equation here, and I get down here, it's going to be the vertex down here at negative 2. Good. Now, my parabola has a positive leading coefficient, so it's going to open up. Because the inequality here, okay, because the inequality here is just greater than, not or equal to, I'm going to use a dotted line. And now let's take a look here. This is y is greater than that parabola. Again, I'm going to put my pencil on that vertex, and I'm going to shade above. And again, we are inside, if you will, that parabola. Or better stated, we are shading above the parabola. Now, but let's take a look at a test point again. Let's just make sure that that makes sense. And because the point 0, 0, because the origin isn't on the parabola, it's not going to be confusing to use it. If you pick a point that's on the parabola, that's not really going to help you here. But let's pick 0, 0 as a test point here. Let's just see if that works. Is 0 greater than 2 times 0 squared minus 12 times 0 plus 16? Now, I did not shade over here over the origin, so I'm hoping that this is false. Okay, because that would be consistent with what I just drew there. So is 0 greater than, let's just figure this out, 2 times 0 squared, okay, that's going to be 0. Negative 12 times 0, that's going to be 0. Plus 16 is going to give me 16. Is 0 greater than 16? Nah, that's false. So that's not true. So the origin does not satisfy that inequality. And that implies that every point outside that parabola will not satisfy that inequality, or below that parabola will not satisfy it, so you shade the other side. Okay, that's how you do that. That's how you go from the inequation to the graph. Okay, now we're going to go in sort of the opposite direction. I'm going to take the graph, and we're going to go backwards and get you the equation for this. Okay? So now, let's take a look at this. First of all, notice that it's a dotted line, so it's either going to be y is greater than or y is less than. One of those two right there. If I take a look at the vertex, notice that the shading is above it. Okay? So I can tell you right now that's going to be y is greater than. Y is greater than some expression here. Now, I'm going to kind of bounce back and forth. Well, we're told what form to put these things in here. I was going to bounce back and forth between them anyway, but I just saw here we're given what form. We're going to do this one in vertex form. So I can see right here that my vertex is the point, what is that, -1, -4. Whoops. -1, -4. So right now, I know that this is going to be y is greater than a multiplied by x plus 1 squared, or minus -1 squared, minus 4. Now, I am missing, okay, I am missing the a value. But that's okay, I can figure that out because I can see that I've got a y-intercept here, 0, -2. So just for the time being, I'm going to ignore that inequality. I'm going to just take a quick look at this expression, at just the parabola. I don't really need the shaded region right now. I just want to get the equation of the parabola. So I don't need the greater than. So now I'm going to plug in that x-intercept here, so the y-intercept, 0 plus 1 squared minus 4. Now, I know from experience that I should bring that -4 over first. Add that 4 to both sides to get 2. And then I should evaluate this. 0 plus 1 is 1 squared. It's 1. Okay, well, there it is. So my a value is going to be 2. So plugging that back in, I get y is greater than 2x plus 1 squared minus 4. Okay, let's take a look at this next one. Okay, notice it's a solid line, so I know it's going to be y is greater than or equal to, or y is less than or equal to. That's pretty easy to tell. If I take a look at the vertex and look where the shading is, again, if I move my pencil in the direction of the shading, I'm going down. So I know the line is going to be y is less than or equal to. Okay, now, well, they want this in standard form, which means I'm going to have to expand this out. And ultimately, that means it doesn't matter whether I do this, whether I start this in vertex form or in root form. So I tell you what, let's start it in root form. So I'm looking at my x-intercepts there, and they're pretty easy to see. I don't know what my stretch value is going to be, but I've got a root here at -2, so that the corresponding factor is x plus 2. I see that it goes through 6. The corresponding factor here will be x minus 6. It's a good start here. Now, I can also see that I've got this vertex here, and the vertex is the point 2, -4. Now, the reason why that's important here is because I need to figure out what the stretch value is. So, again, just as I've done before, I'm going to ignore the inequality right now because all I really need is the parabola, not the shaded region, just the parabola. So I'm going to focus specifically on the line. So that'll be y is equal to a times x plus 2, x minus 6. And now let's plug in that point. -4 is equal to a, 2 plus 2 multiplied by 2 minus 6. All right, let's evaluate that. So that's going to be a times 4 times -4. Oh, now those -4s, I will divide both sides by -4, that will cancel. Then I'll divide both sides by 4 to get that a is equal to 1/4. Now, I can write that back into the equation. Y is less than or equal to 1/4 x plus 2 x minus 6. Wonderful. Now that's not the final answer though, because the question told me to write this in standard form. So what I've got to do is I got to expand that out. Oops, keep doing that. So y is less than or equal to, let's leave the 1/4 out for a second. This will become x squared minus 6x plus 2x, so minus 4x minus 12. All right. Now, to finish that off here, you might write that as y is less than or equal to 1/4 x squared minus x minus 3. Okay, and there we go. Okay, let's do another one. We want to express this one in standard form. Okay, now this time maybe what I'll do here is I will go through vertex form. Okay, why not? So first of all, notice that it's a solid line, so I know it's going to be y is greater than or equal to, or y is less than or equal to something. If I look at the vertex and I look at which way it's shaded above that vertex, so I know it's going to be y is greater than or equal to. And like I said, I'm going to start this in vertex form, just because, I mean, I have to put it in standard form, which involves expanding, but that's a hard one to go directly to. So I've either got to go through vertex or through factored form, and this is just as easy. So my vertex here is the point -1, 2. So it'll be x plus 1 squared plus 2. Now, I got to pick a point that it goes through that I can use to substitute in, and let's just choose that x-intercept there. So I've got this x-intercept here, 1, 0. So now I'm going to focus just on the parabola, not the region. That's why I'm dropping the inequality, just the parabola. And I'll plug in that x-intercept there. So 0 is equal to a 1 plus 1 squared plus 2. Experience tells me I should bring that 2 over first. -2 is equal to a. 1 plus 1 is 2, squared is 4. And when I divide, I will get that a is equal to -1/2. Excellent. So now let's plug that in. Y is greater than or equal to -1/2 x plus 1 squared plus 2. Almost there. Almost there. Because I have to expand this out to put it in standard form. That'll be -1/2. Let's deal with this square first here. So it'll be x squared plus 2x plus 1 plus 2. Okay, that's the q value of the vertex there. Let's distribute that -1/2 through. So -1/2 x squared minus x minus 1/2 plus 2. Or finally, just putting together the like terms, and all I've got are those constants, -1/2 x squared minus x, and that is going to be plus 3 over 2 when I add those two values together. And so there you go in standard form. All right, one more. Express this one in factored form. Okay, now notice it's a dotted line, so I know this is going to be y is greater than or y is less than. Okay, not or equal to, because we're not including the parabola. If I want to know which one it is, I put my pencil on the vertex, shade or slide it in the direction of the shading, and that's down. So it's got to be y is less than. So y is less than. Now in this case, we want this thing in factored form. Okay, so I got to take a look at the roots. Now there's going to be a stretch. I don't know what it is. But I've got a root here at -4, so it's going to be x plus 4. That's the corresponding factor. +2, so x minus 2 is the corresponding factor. Now, I just need another point that I can plug in there. And I'm pretty lazy. I'm always looking for intercepts there. So let's use that y-intercept, 0, 4. We'll plug that in. Now, again, at this point, we're only interested in the parabola, not the region, because I'm trying to come up with the equation of the line, so I don't need the inequality. Let's plug that in. 4 is equal to a multiplied by 0 plus 4, 0 minus 2. 4 is going to equal a multiplied by, okay, this is going to be, well, +4, -2 is going to be -8. And when you divide, we're going to get that a is equal to -1/2. So, putting that all together, we get y is less than, shaded below a dotted line, -1/2 x plus 4, x minus 2, and that's in factored form. I don't have to go any further because that's what they were asking me to do, just to put it in factored form. Okay, and so there you go. I hope I hope you're getting used to this idea of shading above and below. If you use the idea of inside and outside the parabola, it looks different whether it opens up or down, and so you're going to have to be really careful with that. Just be very, very deliberate. If you just concerned with shading above or below that vertex, it's actually a little easier. There's a little bit less that you have to remember as you're working through those questions. I hope that helps.